In this chapter, we're going to explore how security professionals move beyond just manual testing to automate customized attacks against web applications. This isn't just theory, It's a fundamental part of how modern, effective security testing gets done, and we're going to break it all down.
So this question really gets to the heart of it, doesn't it? The simple answer is, you wouldn't. I mean, think about it. While every web application is unique and needs a creative approach, trying to test everything manually is just, well, it's a losing battle. Imagine clicking through thousands of pages or filling out hundreds of forms by hand. It's not just mind-numbingly slow and exhausting, you're also bound to make mistakes. When you're up against a massive application, the manual approach just can't keep up. And that, right there, is where automation becomes an absolute game changer.
Here's a great way to think about it. Manually testing a big application is kind of like trying to find one specific sentence in a massive library by reading every single book page by page. I mean, you could do it, but it would take forever. Automation, on the other hand, is like building a custom robot that knows exactly what you're looking for. It can just zip through the library and scan every page in a fraction of the time. As you can see here, we're trading something that's slow, error-prone, and frankly draining for something that's fast, efficient, and incredibly powerful. So here's our game plan. We'll start with the why, that's the automation advantage and the three main types of attacks. Then we'll dive into the how, the anatomy of an attack, and figuring out when you've actually succeeded. After that, we'll explore the tools of the trade, and we'll wrap things up by looking at the roadblocks that developers put up and how we can get around them. So let's jump right in with the main ways these automated techniques are used. There are really three core scenarios where a security professional is going to turn to customized automation to seriously level up their attacks. These are the big three. First, we have enumerating identifiers, which is a methodical search for things like valid usernames or account numbers. Then there's harvesting data, where we use a weakness we found to pull out huge amounts of information. And finally, there's fuzzing, which is a super powerful, if a bit chaotic, technique for finding brand new vulnerabilities. Let's dig into each one. First up is enumerating identifiers. So imagine an application uses a URL parameter, like pageno equals 10069, to show you some content. As an attacker, you don't just care about that one page. You want to find all the valid page numbers. Trying to guess them manually is a total non-starter. But with automation, you can just write a simple loop to test every single number from, say, 1 to 20,000, and very quickly build a complete map of every accessible page. Finding those identifiers is powerful, but what often comes next is data harvesting. Let's say you found a whole list of valid user IDs. If you find another flaw that lets you view any user's profile, you can then automate a script to go through your entire list, visiting each valid profile and scraping all that sensitive info. We're talking names, emails, phone numbers. This is exactly how a small crack in security can be blown up into a massive data breach. It's why this stuff really matters. And our third technique is fuzzing. Now, if enumeration is like using a sniper rifle, fuzzing is more like using a shotgun. It's a lot less targeted. You take every single input the application has, search boxes, login fields, URL parameters, you name it, and you just bombard them with a massive list of weird, malformed data. Think random symbols, snippets of code, crazy long strings of text. Your goal is to make something break, to cause an unexpected error, because those errors often point directly to hidden vulnerabilities, like SQL injection. Okay, now that we get the types of attacks, let's get into the mechanics. No matter what technique you're using, your success hinges on one absolutely crucial thing: knowing when you've actually landed a hit. You have to be able to automatically tell the difference between a successful attempt and a failed one. If you can't, you're just firing blind. The key is finding a consistent, reliable difference in what the server sends back to you. This table shows the most common tells. The classic one is the HTTP status code, a 200 OK for a valid page versus a 404 not found for an invalid one. That's easy. But you can also look at the length of the response. Maybe a valid user profile is 10,000 bytes long, but an error message is only 500. That difference is your signal. You could even search for a specific word in the response, like welcome after a good login. Sometimes the clue is even more subtle, like getting redirected to a different URL, or even a tiny delay in how fast the server responds. All right, we've covered the what and the how, so now let's talk about the with what. It's time to look at the actual tools security pros use to launch these attacks, from basic custom scripts all the way to powerful professional-grade software.
But before we get into specific tools, I really want to hammer this point home. This quote is critical. The success of any automated attack lives or dies by how reliably you can spot that hit. Sometimes you won't even know what a successful response looks like before you start. So the best strategy is to cast a wide net. Monitor everything: status codes, response links, headers, and just hunt for any deviation from the norm. That one weird response that sticks out, that's probably your key to success. On a fundamental level, you can always just write your own script. The source material gives an example of a simple tool, and we don't need to get lost in the code, but the logic is what's important because it's universal. You define your target URL, you generate your list of payloads, like a sequence of numbers, and then you just loop through them, sending one request for each and analyzing the response to see if it's a hit. And this is what you get. The script does all the boring, repetitive work and then just hands you a clean, simple list. You can instantly see which page IDs gave you a 200 OK. Those are your hits, and which ones failed. You've basically turned thousands of repetitive requests into a clear, actionable list of valid targets. Now, while scripts are great, professional tools like Burp Intruder are a total game changer. Let's do a quick visual walkthrough. First, you capture a normal request from the application. Then, as you can see here, you just highlight the specific parts of that request you want to attack. Maybe it's a session cookie or a username parameter, and you mark them as payload positions. This tells the tool exactly where to inject its data. Next up, you choose your ammunition. Burp Intruder is packed with powerful payload generators. In this example, we're setting up a simple number sequence to cycle through hexadecimal values, which is perfect for trying to guess valid session tokens. You just tell it where to start, where to stop, and how to step through the numbers, and the tool handles the rest. And this is the payoff. Once the attack is finished, the results pop up in this clean, sortable table. This is where you can easily spot the anomalies. A simple click on the status column brings all the 200 OK responses, your hits, right to the top. And notice how a few of those hits also have a much longer response. In a real-world scenario, that could be a huge deal, maybe indicating you've just hijacked the session of an administrator. This is the kind of powerful analysis a pro tool gives you. Of course, developers know all about these techniques, and they don't just sit back and let them happen. They build defenses specifically designed to block automation. So now, let's look at the other side of this chess match: how to overcome the common barriers that stand in our way. These defenses usually fall into two categories. First, you have what we can call session puzzles. A great example is an anti-CSRF token. Think of it as a secret one-time password that the application requires with every single request. If your tool keeps sending the same old token, it gets blocked. The solution is to use advanced macros that can automatically grab a new token before each request. On the other side, you have human puzzles, and the most famous of these is, of course, the CAPTCHA. We've all run into these. A CAPTCHA is just a test designed to tell humans and computers apart. It gives you a challenge, like reading some distorted text, that's supposed to be easy for a person to solve, but really difficult for an automated script, effectively stopping bots in their tracks. So do attackers need to build some sophisticated AI to beat these things? Not usually. The cleverest approach is to attack the implementation of the CAPTCHA, not the puzzle itself. And you'd be amazed how often there are simple logical flaws. Sometimes the correct answer is accidentally sent to your browser in a hidden field. Other times, an application will let you solve one CAPTCHA and then reuse that same solution for 1,000 requests. And my personal favorite, sometimes you can just bypass it entirely by deleting the CAPTCHA parameter from your request. All right, we have covered a huge amount of ground here, from the core concepts of automation to the tools of the trade and the defenses we have to overcome. Let's bring it all together with a few key takeaways. Here's what's most important to remember. Automation is what takes a slow, manual security test and turns it into a fast, scalable, and powerful attack. Its three main uses are enumerating identifiers, harvesting data, and fuzzing. The absolute linchpin for any successful attack is finding that reliable hit indicator to tell success from failure. And while you can write your own scripts, professional tools make the whole process way faster and more effective. And finally, remember that even modern defenses like CAPTCHA can often be defeated by looking for simple flaws in how they're implemented. So I want to leave you with this final thought. Automation gives us incredible speed and scale, but the tools themselves aren't smart. They're just following orders. The real ingenuity, the art of hacking, it all comes from the human element. It's an understanding an application's hidden logic, in creatively finding that one subtle indicator of success, and in seeing the pattern in the data that everyone else missed.
That's the difference between simply running a tool and being a truly skilled security professional.